Okay, good morning, everyone. Today is our last class meeting before the final exam. So just again to reiterate, the final exam is going to be on Thursday of next week. It will take place at 9:30 in the morning, so same time as our class time, but it will go till up to 12:15 p.m. So you'll just show up, you know, like you normally did for other exams, and get your camera set up, and then I'll send the test out. So same protocol as before. And that's it. Yeah. Any questions on the final as far as the date, time, anything? Anyone have any conflicts with that? You shouldn't, but okay. The other thing is, you know, what are you allowed to have during?
I should be good for the final, but I might have my brother running around and I might have to like step away a couple times
Okay.
because my mom is having surgery this weekend or Monday
Okay.
and won't be able to lift anything, so I might have to get things for her.
Okay, I understand. That's fine. For the final, what I'd like to do is I'm going to allow you to have a reference sheet for the final. So, excuse me, hold on, I dropped something. Okay, so one standard sheet of paper, front and back. You can put any formulas, any steps, any procedures. You just cannot have worked out problems on this sheet. That is allowed on the exam, all right? But you will also turn this in with your work. So make sure that it doesn't have worked out problems on it. You can type it up, you can write it, doesn't matter, just one sheet front and back. Okay, any questions on that? No? Okay, so we just have, I just want to cover one short topic, and then we're going to start talking about the review, all right? The thing I want to talk about today is something we had started last time. Let's see here. We started talking about conversions, right? Or so, talking about the different systems of measurement, right? Metric versus imperial. And when we had finished, we were starting to look at, you know, how you could convert something like feet to miles. What I'd like to do is a few conversions where we go from metric to imperial or imperial to metric. So let's do this. Let's start with an example here. Oh, why isn't this working? Oh, wrong pen. Oops. So, all right, so let's try this. What if you had, let's say 57.4 feet, and you wanted to convert that to M. So M would stand for meters. We talked about this last class. So we want to somehow see if we can get feet to meters. Well, you're going to need some sort of conversion chart for this. And this chart, I would provide this to you on the test. Okay, so you would not have to put this on your reference sheet. If I'm going to ask you to do any conversions from one system to the other, then I'll give this to you. All right, so we are trying to go from feet over to meters. So is there anything on here that goes from feet to meters? And remember, these are both measurements of length. So we're looking here at length. And do we have any feet going to meters? Well, right here, this one right here. right? That converts your feet to meters. So what I'm gonna do is I'm gonna copy this over here. And let's go back to the problem. I'm gonna write this down, or I'm gonna paste this in here. And now here's how we're gonna do this. We start by writing out the left-hand side, 57.4 feet, and then put it over 1. So you're gonna basically make a fraction out of it. And then we're gonna multiply by something here. And what we want is for the feet to cancel. So we know we're gonna need feet down here, and then we want meters to appear, so we're gonna have meters on top. So we're wanting these feet to go away. That's why the feet's on the bottom and the meters are on the top. Now, the question is, what do we put there? So we go back to this relationship, and remember a few weeks ago, I was talking about whenever you have some sort of equivalence like this, what we can do is we can set up two ratios from this. One ratio we could do would be to take the 1 foot, I'm going to write FT instead of FOOT, and divide it by 0.3048 meters. Okay, the other thing we could do is put the 0.3048 meters over the 1 foot. And you're free to use either one of these. Now, because we want our meters on top and our feet on the bottom, we're going to use this one, and we're not going to use that one. So all I do here is plug in 0.0348 meters over 1 foot. And then you just go ahead and do what you normally do it with fractions. We'll cancel the feet out and then just multiply across. So I'll need my calculator. I'm going to take 57.4 and multiply it times this. So 57.4 times I wrote that down wrong, sorry. It's 3048. Sorry about that. So I multiply that 0.3048 and I get 17 point, let's say about 17.5. And since the feet went away, the only unit left there is meters, so we put 17.5 meters. And that's it, okay? So again, the idea is that you're going to take what you're trying to convert, you're going to put it in a fractional form, then you're going to look at what you're going to need to cancel the unit out, and then go ahead and use the relationship, create the ratios, and then pick the one that works for you. Let's do another one. How about this one? How about 2.5 kilometers is equal to how many yards? All right. So again, I'm going to go back and I'm going to look at my conversions here. Let me get all this crap out of here. Okay. So I'm trying to go from kilometers to yards. I'm going to put YDS for yards. All right, so where in here, these are both measurements of length, right? So I'm looking in here and I'm saying, okay, do I have anything that goes from kilometers to yards? And I look, and the only thing I see that even has a yard in it is this. 1 yard is 3 feet, right? So I have a relationship between yards and feet, but I don't have a relationship between yards and kilometers. So I need to somehow like build a chain, a bridge that will get me all the way from kilometers to yards. So I have another thing that has kilometers here, and kilometers is related to miles in this conversion chart. So here's what I'm thinking. I can go kilometers and I can convert that to miles. Okay, I should be able to do that with this relationship. And then is there any way to get from miles to yards? Well, I can get from miles to feet, can't I, with this one? 1 mile is this many feet. And then once I have feet, I can get from feet to yard. Does that make sense? I have to start to build this little chain up. So miles, I'm going to go to feet. And then feet, I will go to yards. All right, I'm going to need all this. Let me grab it. All right, so how am I going to do this? First thing I'm going to do is I'm going to write down the thing I'm trying to convert, which is 2.5. And I'm going to put kilometers here, and I'm going to put over 1. Now, we said the first thing we're going to do is go from kilometers to miles, right? Kilometers to miles. So I'm going to multiply this times a fraction that will kill off the kilometers, right? The kilometer needs to cancel. And then I need miles on top. I put MI for miles. I can't put M because if I put M, that stands for meters. So I put MI for miles. All right. Now I have to figure out the ratio to use. I'll do that in a second, but think about what's happening here. Once we fill this in, we will be in miles. So now that we're in miles, I'm now going to multiply again, but now I want to go from miles to feet. So I want the miles to cancel and I want my feet to appear. So the miles will cancel and the feet will appear, and I'll use the green one to do that. And then once I get to feet, I'm trying to get to yards. So I'll multiply again, feet to yards. I put the feet on the bottom because I want it to cancel, and then yards on top. And that will give me yards at the end of everything. Does that make sense? Go from kilometers to miles, miles to feet, feet to yards. Now, the way that I'm not going to write out for each one of these, I'm not going to write out the 2 possible fractions. Okay, so let's look at the first one. Miles and kilometers is this right here in blue. So I'm just going to write down, I have 1 mile is 1.609344 kilometers. And then the next one is feet and miles. That's the one in green. So it says here I have 5,280 feet in 1 mile. So I'm just using the numbers here. And then the last one here says that 1 yard is 3 feet. So 1 yard is 3 feet. And now I'll cancel all my units. The kilometers cancel, the miles cancel, the feet cancel. That will leave me with an answer that just has yards. Okay, so here I'm ready to get my answer. I'm going to first multiply all the numbers across the top. Okay, I'm going to do that on my calculator. I don't need to multiply by 1, but just making sure you understand we're multiplying all the numerator numbers together. So you multiply the top, you get 13,200 over. Now on the bottom, you have to multiply all the numbers on the bottom. So 1 times this, times this, times this. So 1.609344 times 3. That gives me 4.828. And now I just divide that. I do 13,200 divided by the previous thing. And we should get an answer. It's approximately 2,734 point something. I'm just going to say yards. That's approximately that much. Approximately. So on the test, you know, round 1 or 2 decimal places, that's fine. I'm more concerned with you showing me this part. All right. And I do expect for you to do something. I don't want you to go from here straight to an answer, because that means you either looked it up on your phone or on a computer, which you're not supposed to be doing. It should require you doing some sort of conversion here. Now, in the real world, you would go to a computer and let it do it. All right. Questions on this? Building up this chain to get things to cancel. Y'all are okay? All right, every example I've given you so far today has been an example of length. when you do something like area or volume, things get a little bit tricky. All right, so let me show you. What if I write this down? You have 2 feet squared. Hold on a second. You got it. All right. My dog is not feeling well today, so he's like trying to get out of here. All right, so 2 feet squared, and I want that to be converted into centimeters squared. Okay. So first thing you have to realize here is that we're trying to do a conversion for area. How do we know it's area? Because the units are squared, right? I talked about this last time. That's how we let you know we're talking about area. So is there a way to go from feet to centimeters? All right, let me go back to the sheet here. Well, the only thing we have for area here is acres, square feet, square miles, acres, square kilometers, and what is this, hectares? We probably never even deal with that in your life. So I don't see anything with area that has feet and inches, right? I'm sorry, feet and centimeters, agree? So do we have anything? Well, back up here with length, let me erase the yellow here. We do have a way of getting from what we can get from feet to inches, right? We can get from feet to inches, and then the one above it allows us to get from inches to centimeters, right? So watch how I'm going to use this. This is going to be tricky. Students a lot of times make mistakes on this. Okay, so I'm going to put this over here. All right, so here we go. I'm going to go ahead and write down what I'm trying to convert, which is 2 feet squared over 1. Now, the first thing I want you to understand is that this is equal to, I'm not multiplying by any feet, but this is the same as 2 feet times feet over 1. Okay, that's weird, but that's what feet squared means, right? When you measure the area of something like a rectangle, you're measuring this side, which is a certain number of feet, question mark, and then this side is a certain number of feet. Then the area here is the unit feet squared. We talked about that last class, but feet squared just means this foot times this foot, that's foot squared. So foot times foot. Now, why is that important? Well, I need to somehow get from feet to centimeters, right? Feet to centimeters. So I know I can get from feet over to inches right here. And then I can get from inches, I can get to centimeters using the blue one, right? So what I'm going to do is multiply. Let me get rid of the feet first, okay? So I have a conversion where I want the feet to go away and inches to appear. So I put feet here and inches up here. I'm put IN with the dot. Now, is that going to be enough? Is that going to work? Will it cancel my feet out?
It'll only cancel 1 feet, not the other.
That's right. It only cancels one of them, which means I have to do it again. I have to do it twice to get both of the feet to cancel. All right. Now let's go ahead and fill this in. I know there's 12 inches in 1 foot, so I put 12 here, 1, 12 here, 1. Okay, now at this point, my feet will have canceled, and now I would actually, what would my units be right now? If I stopped right here, what would my units be? The feet are gone, but now I've got what?
Inches.
Inches squared, right? Squared inches is what I would have. So we've gone from squared feet to squared inches. But I don't want inches, I want centimeters. So now I'm going to use another multiplication. and I want to get rid of the inch. And I want centimeters to appear, and that's using the blue one up there. But again, that's not enough because I have 2 of the inches there, so I've got to do it twice. And I know that there are 2.54 centimeters in 1 inch, 2.54 centimeters in 1 inch. And by doing it twice, I get the inches to cancel once and inches to cancel twice. And check it out, when I'm done, I'm going to have 2 centimeters there, which means my answer is going to be centimeters squared, which is what I need because it's a measurement of area. So this will be equal to, we're ready to do this. I know I'm going to have centimeters squared. And now I need to multiply across the top. So remember, this was my equal sign, so ignore this, all right? I need to multiply 2 times 12 times 12 times 2.54 times 2.54. I need all of that over what? 1 times 1 times 1 times 1 times 1. Okay, so I won't even have to worry about the denominator. I just have to do the top. So 2 times 12 times 12 times 2.54 times 2.54 is about 18,000, or no, 1858.1 maybe centimeters squared. So I want you to, I want to try and make sure you understand this visually, what we've done here. What we've said is that if you were to take, let's say, a rectangle that was 2 square feet, that means maybe this side is 2 feet, this side's 1 foot, okay? That if you were to try and figure out how many square centimeters there were, so centimeter, and if you get a ruler out, a centimeter is really small. So this is saying that there are, if you take a little patch, a little thing here that's 1 centimeter by 1 centimeter, and you start putting these in here, there will be about 1,858 of them in there. Okay. What do y'all think? That's a little harder, right? With the square unit, you just have to keep track of what you're doing. Let me see on the review. Did I go cubed unit on the review? I don't remember. I did. Okay, so I need to do one of these. This will be our last one. Okay, so what if we wanted to go and convert 6 yards cubed into cubic inches? So when you see the cubed here, you're thinking again of volume. So this is like a box. Instead of a flat sheet of paper, it's like a 3-dimensional box. You have 6 cubic yards of something, and you want to know how many cubic inches that is. So we need to get from yards to inches. And I believe we can do it. See how we can, let's see what we can do to build this thing up. All right, I want to go from yards to inches. So I can get from yards to feet, right? And then I know how to get from feet to inches, right? So there's a clear path here. I can go yards, that to feet, and feet I can get to inches. I just have to take care of the cubed units. That'll be the part that we have to pay attention to. Let me do it here. I put 6 cubic yards. So I'm going to put yard, yard, yard. I have 3 yards that I have to cancel out over 1. All right. I need to get that to inches cubed. So the first thing I do is get rid of the yards. And I have 3 of them to cancel out. So I have to get them first to feet. So I'm going to cancel with the feet here. Sorry, wrong way. Yard here, feet here. Another one, feet, yard. Another one, feet, yard. And that should get my yards to cancel. Now, we know that there are 3 feet in 1 yard, 3 feet in 1 yard, 3 feet in 1 yard. That's just using this yellow relationship. So now I'll be in cubic feet of 3 feet that I need to go away. And so now I'll bring in the other conversion that will kill off the feet and get me to inches. And I need 3 of them again. And I know that there are 12 inches in 1 foot, 12 inches in 1 foot, 12 inches in 1 foot. And now I'm ready to multiply. Let's just do the canceling. Yards gone, yards gone, yards gone. Feet, feet, feet. And now I'll be left with inches, 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 which means my answer will be in inches cubed. And now multiplying across the top, this is going to be a big number. So we have 6 times 3 times 3 times 3 times 12 times 12 times 12. Yeah. 279,936. That's how many cubic inches are in 6 cubic yards. All right. That's it. Let's call it a wrap there. So y'all want to talk about the final? I sent out the review, didn't I? Did everyone get that? I sent it out as an email like
Yes.
2 days ago, I think. So I kind of wanted to just ask you how you wanted to, like what you wanted to do here for the rest of the class period. We have, let's see, the review has 8 questions. That's a lot, 27 questions. So I don't think I have enough time to go through the whole review, but I can do some of it. So I was thinking maybe you could request something here, like what you'd like to see.
Could you maybe do number 9?
Sure. So before I do it, let me just kind of talk about the review. This goes back to the very beginning of class. It's just little kind of bits and pieces of each of the exams. So you have, perform an operation, solve for X, greatest common factor. This is simplify, so you're multiplying this through. This actually, we did this at the end of class, but it's early in the review for the final. This is the proportion problem. And then the other one is like price and finding out how much something costs after a discount. With tax, we did that. Sketching a line, that was early in the semester. There were 2 ways to sketch lines. There was the intercept method and then the slope intercept method. So 7 and 8, I don't tell you which method to use. I'll let you do what you want. And then we get to number 9, which is this is a word problem, but it's a linear function. We're about to do that one. And then we start sketching. So remember, we learned how to sketch parabolas. And then this is an application problem with the parabola. Then we learned how to sketch polynomials. And then we learned how to sketch rational functions. These were ugly. And then these are exponential functions. And then we have that interest formula, the shampoo formula here. And then this is a system of equations. This is like a problem I gave you last week. And then we get to what we covered kind of last time and today, which is converting scientific notation, and then also conversions. So that's kind of like the layout. You should expect the final to be similar. I will warn you that there is going to be at least one problem on here that I have no control over. all right? The math department, every class that we teach, there's one problem on the test that we don't get to see until the test. And we hand it to every student, so I don't know what it's gonna be. You'll do what you can on it, and that's it.
Will there
I mean-
be logarithm problems? I'm not seeing any, but
Yeah, you know, when I put the review together, I realized afterward that I didn't do anything with logs, right? And so I think what I would like for you to do is right here on this problem, number 20. What I think you should do, both these problems are pretty much the same. Like they're the same basic problems. What I'd like to do is modify it where I ask you something like, how long does it take to double your money? So look back in your notes. I'll even tell you when that was, because I will ask a question like this. Again, the review is a guide, it's not everything, but logarithms, I do want to ask you something on that. So where's the one? Exponential. This was the shampoo formula. Log functions. Here we go. So it's probably the next day. Yeah. Here we go. There we go. Something like this. This is on November 4th, right in the beginning of class. I said, if you put a certain amount of money into an account at a certain interest rate, how long will it take to do this? And you have to eventually use a logarithm to do this. So yes, the answer is yes. You should be able to do something like this. But that's about the extent of it. I'm not going to go further. And there was a whole homework assignment where you did solving log equations. I'm just going to keep it applied to the to that one word problem. Okay, you ready? I've been asked to do number 9. Before we start, give me just a moment, okay? Let's take a little 2-minute break. I got to go check on my wife real quick. She wasn't feeling good. Let me just make sure she's okay. I almost canceled class, but I was like, you know what? I'm not going to cancel our last day. That's no fun. I'll be back. Okay, everyone. Sorry about that. I'll get my video here going in a minute. Someone asked if I'm going to post the answers, and I believe I have most of the answers. Here, let me just check. In fact, yes, I do have the answers for most of them, not all of them, though. Let me see how far it goes. Right now, I've got up through kind of spotty here and there. I've done most of them. So I'm going to use this, if y'all don't mind, instead of working out the problems, I'm going to just show you the answers and then kind of talk through them. Is that all right with everyone? Rather than work through each one?
Yeah.
Okay, so here's the problem number 9. So you're told you have an electric bill that charges $12 per month for service and 4 cents for every kilowatt hour used. So find a linear model. So when we say linear model, that means that you should have some equation that looks like a line, y equals mx plus b. Okay, it should look like a line. Now, we're going to, instead of using y, I'm going to use c for the cost. All right, so we're trying to find a linear model which gives the cost as a function of the number of kilowatt hours used x. So in this problem, we have first the 12, which is our fixed cost. That's the thing that never changes. Regardless of how much electricity I use, I have to pay $12 for service. That's going to be like the y-intercept. That's the fixed cost. The $12 goes here. So that's like the B. And then the 4 cents for every kilowatt hour used, that's variable. That changes, depends on how much I use. So I take 0.04 and multiply it times x. And that's our cost equation, and that's the answer to part A. Questions on that? For part B, how much will it cost in a month if I use 720 kilowatt hours? All that means is replace the x with 720, multiply these, add 12, and you get $40.80. Just make sure that when you do this, you put a dollar sign. Let me know you know that the answer represents money. And then in part C, it says, hey, instead of me telling you how much electricity you use and you give me the cost, I'm going to give you the cost and you're going to tell me how much electricity you used. So if the bill's $320, how much electricity did we use? Well, now what we do is we take this equation and we set the C equal to 320. So we plug 320 in right here, and now we solve this equation. So to solve this, I first subtracted 12 on both sides. I didn't show it, but I subtracted 12 on both sides. And then after I subtracted 12, I divided both sides by 0.04, and I got 7,700 kilowatt hours. Questions? Which one would you like to discuss next?
Can we look at number 8?
Number 8. Going the wrong way here. So sketching this line, let me see. Let me make sure I have number 8 done. Yeah. Okay, so for number 8, here's the line. The way that I did it is I did the intercept method, all right? So to do the intercept method, I'm first gonna find the x-intercept. And to do that, I set y to 0. So if you take this equation and you replace the y with 0, it kills all that off. And so all you're left with is -2/7 x equals 1, which is what I wrote down right here. And then what I did is, because I had -2/7 x equals 1, I had to divide both sides by -2/7 in order to get the -2/7 to cancel and leave me with an x on the left. And then on the right side, I had 1 divided by a fraction. So 1 divided by a fraction is the same as keep dot flip. So this is 1 times the reciprocal of this, and 1 times anything is itself. So that's why the right side is -7/12, which I put as a decimal. negative 3.5. Does that make sense? Anyone got any issues with that part?
No.
Okay, so now to find the y-intercept, what I did was instead of letting x, instead of what we did here for the x-intercept, setting y to 0, what we do here is we set x to 0. So that kills off this, and all I'm left with is 1/14 y equals 1, which was right here. It was actually right there. And then I multiplied both sides by 14 to kill off the 1/14 and give me just y, and I get y is 14. So now I have the x-intercept and the y-intercept. So I just drew on a graph my x-intercept right there. See, it's on the x-axis, negative 3.5. I just put it right here. And then the y-intercept was up on the y-axis, right? This is the y-axis. I just went up 14, put a dot. And once I had those two, I just drew, well, it's not a very straight line, but it's supposed to be a straight line through those 2 points. Is that all right?
Yeah, that makes more sense.
Okay. The fractions can be a little bit tricky. Go ahead.
Oh, could we do the logarithm one?
So okay, so what do you mean by the logarithm one?
Didn't you say there was gonna be an equation where you have to do a logarithm?
Yeah, okay, so I can give you, how about I just give you an example? All right. Okay, so like an example of a problem that would involve logarithm would be something like this. How long would it take to turn 5,420 into, let's say, $8,500 if the money is placed into a simple interest account at a rate of, let's say, 2.15%. Question. So you need to know at this point, because it's simple interest, you need to know we're using the shampoo formula, A equals PE to the R times T. PERT. Wow, I messed that up. Sorry. E to the RT. The R is up on the exponent of the E. So what do we know here? Well, we know how much money we put in, right? Initially, we had $5,420. That's the amount that we put in. That's going to be P. All right. And then we know how much money we want at the end of it all, 8,500. That's the amount that we want at the end. So we'll replace that there. And then we also know the interest rate is 2.15. That's going to be replacing that. But remember that when we do this, this has to be converted to a decimal. So I move the decimal point 2 places to the left. Don't forget that step. So this is what we have. We have 8,500 equals 5,420 E raised to the 0.0215 T. So we're trying to figure out how much time it takes, right? We're trying to figure out what time it takes. How long would it take for this to be true? So can anyone tell me what the next step is?
Wouldn't we divide?
Yep.
Okay.
Divide both sides by 5,420. Okay, divide by 5,420. What I'm trying to do is get that E thing by itself. Okay, you're going to get a decimal here. You're going to get 1 point, let's say 568 approximately. equals e raised to the 0.0215 t. Who remembers the next step? We're trying to get that t out of there. This t is up in the exponent. We want it out of there. How do we get variables down from the top like that? We have to bring in a what?
Fraction.
No,
I think we have to take the t to the other side. Then bring,
how? You can't just bring the t down. Just, there's nothing you can do to pull that t down. You have to bring something very special in to make this happen. So let me just remind you. You remember the whole idea of the logarithm? This idea of this thing that was like a loop. Remember that? That look familiar? Or does it not look familiar at all?
It looks familiar.
You
Yeah.
equal the top part and raise the bottom, right?
Yeah, there's different ways to look at it. So look back here. Where was it? See, this is when I was talking about here. What is a logarithm, right? What is a logarithm? So I'm trying to basically rewrite this. I'm trying to rewrite it. But I want to use a log to do it, use a logarithm. So first thing I'll do is I'll write down log, L-O-G. Now the subscript here, this thing right here is the same as the base here. So that'll be E. And then I have to use the loop to come up with the rest of it. So E is being raised to what power? So look at this equation. What is E being raised to?
0.0215.
Yeah, so that's what goes here, 0.0215 t, right? And then that must be equal to, and then we're going to put whatever it's equal to right here. So what is this? What is this e to the 0.0215 t equal to?
1.568.
1.568. So I put 1.568 here. And then at this point, you can do this two different ways, but I would just remind you of what this means. What does log base E really mean? It means natural log, the natural log, and you have a key on your calculator for that. That's why it's important to know what that log is. So I'm going to just, on my calculator, do the natural log of 1.568. And that gives me 0.4498 equals 0.0215 t. See, the only way to get the t out of here from the top is to bring a logarithm. That's the only way to do it. There's no other algebra you can do. You can't divide, you can't multiply, you can't subtract. The only way to free the t is to bring in the log. All right. But now we just have a little linear equation. So now I'm going to take that answer 0.4498 and divide it by 0.0215. And I get 20.92 is t. So I need to say what this is. Do y'all know what this is? Is this 20.92 days, months, years? What is it? In this formula, t is always measured in what? Oh, no,
Months.
it's years. It's years. So in this formula, R is the interest rate, t is measured in years. So our answer is this is how many years it's going to take. That's pretty pathetic, isn't it? If you put $5,240 into an account, into a savings account, and they're paying you 2.15% interest, it's going to take 20 years to turn that money into $8,500. That's ridiculous. I'm just making sure my math is right on that. Yeah, okay. Almost 21 years. All right. I would just go back and review. We did do those problems in class. Go watch that lecture again if you feel uncomfortable at all with this. That's part of what a final exam is, right? It's about you going back and kind of touching up on everything again, kind of reviewing everything. I'm giving you a review as a guide so you can go back and know what to look at. It would be impossible to review everything, so I'm just having you focus on these topics. So what else? Anything here look?
Can we do number 16?
Yes, we can. You know what? Let me make sure. Let me see if I worked it out. There it is. Okay, number 16 is your favorite, right? Graphing rational functions. All right. So there's a whole set of steps for this, which means you're going to need to go back and review the steps. Should we look? I mean, they're going to be in your notes, which means they're in a video somewhere, right? Probably in October. Let me see. Wow, look at that. I got right to it. There it is. October 19th, I think on the 20th, no, let's see, 14th. Yeah, so on the 14th is when we started rational functions, and I showed you like the certain properties, talked about what the important characteristics were, gave you a set of steps. And I said that the horizontal asymptotes are the ones that suck the worst. Let me see here. I think there's a set of steps. Oh, no. Go back. Here we go. This was how to find the horizontal asymptotes. So, yeah. Let's see if I have it all together in one set of notes. Yeah, this is pretty much it. All right, so what we do is we find the x-intercepts, we find the vertical asymptotes, find the horizontal asymptotes, we plot all the information, we pick test points. We'll always have one more test point than we have x-intercepts and vertical asymptotes, and then we just draw it. Does that look all familiar? I know it's been a long time. That was like, well, not that long, but.
I struggled with where to put the test points.
You mean which ones to pick or where to plot them once you got
Where to plot them.
Like if they were positive or negative?
Yeah, something like that, or even
Yeah.
picking the points
Were you
and
what?
making sure they were between the right lines.
Yeah, okay. When we get to that part, I'll emphasize that a little more. So let's go through the steps. First thing we do is we find the x-intercepts. How do you find the x-intercepts? You set the numerator equal to 0. So I took the top of this rational function, I set it to 0. I moved the 32 over. I divided by 2, which gave me 16, x squared is 16. I took the square root, I got 2 answers, plus or minus 4. Here's another way you could have done it. You could have factored. You get the same 2 answers. Then I found the vertical asymptotes. To do that, I set the denominator equal to 0. So here it is. I factored out an x, set each one equal to 0. I get 2 x-intercepts. I'm sorry, 2 vertical asymptotes. So right now, everyone, I have 2 x-intercepts and 2 vertical asymptotes. That means I know right now I'm going to have 5 test points. Okay, because I have 2 of these and 2 of those. That's 4 total. So you'll always have 1 more test point than you have these things added up. So I know I have 5 test points. I'll get to that in a minute. Now I need the horizontal asymptote. This was the tricky one. There were 3 cases. You look at the degree of the numerator and denominator. Here they're the same, right? 2 and 2. And if they're the same, then you have to look at the leading coefficient of the numerator over the leading coefficient of the denominator. So I took this number 2 divided by 1, and that gave me 2. And then I went and drew everything. So it's kind of hard to see it here, but what I did first on this is I drew the number line. I put 4, I put an x-intercept. At -4, I put an x-intercept. That's from this. And then I had vertical asymptote at 0, I have a vertical dotted line. And at 9, I have vertical dotted line. And then if you go up to, that's where we have a horizontal asymptote. So I drew a dotted line out the right side and the left side, but not through the middle. Whoa, something happened. Everyone disappeared. Where'd y'all go? Oh, never mind. We're good. Okay. So this is where we pick test points. So to do this, hold on. Okay, so Emily, to do this, what I would recommend if you're having trouble with the test points is just do your x-intercepts and your verticals. Just put those on number line like this. Just these points here. And then just pick test points here, 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 and here on each side of those. So something like -5, -3, that's a 0, so maybe 2, maybe 5, and maybe 10. And then go ahead and put them down here and then test them. Does that make sense, Emily? Or-
Yes.
Now, when you test them, you have to plug them into your original function and determine if you get positive or negative numbers. So I didn't show the work here, but I showed it on one of them. I plugged in -5 and I got a positive number. So at -5, I put a dot above the x-axis. And then at all the other test points, I put dots. And then at the end, I connected them together. So look, I mean, there's no way in 10 minutes, 15 minutes that I can go and like completely reteach rational functions. You're going to need to go back and review them because they could appear on the final. Is that enough on that one?
Yes, thank you.
Okay. How about the acid solution one? Are y'all okay with this one? I did not include this. I don't have the solutions done for this one. Why don't we just set this one up real quick? You wish to mix a 4% acid solution with a 60% acid solution in order to get 8 pints of a 10% acid solution. How much of each do you need? So the way you do this, the way I did it, is I drew a picture. We had a container here with 4%. We're going to add to it some container that has 60% acid. And at the end, we want it to have 8 pints. And we want it to be a 10% acid solution. So we need to know how much of each of these. So I want to know how many pints of this and how many pints of this. We call it X and Y. So one thing I know is that the total number of pints has to be 8. So I know that when I add the two number of pints together, I should get 8. And that's my first equation. And then the other part, the way you get it, is you look at the concentration, you convert it to a decimal, and then you multiply it times the X. So I put 0.04X. That plus this one converted to a decimal, 0.6 times the Y, must equal this concentration multiply or turn to a decimal times the 8. So you have to do 0.1 times 8, which gives you 0.8. And that's your second equation. And now you have a system of equations. Any questions on that setup? I'm gonna work this one out. I gave one of these problems as a homework. No one ever asked me to work it out after I gave it. So what I'm going to do here is I'm going to get rid of the decimals. And to do that, I need to move this decimal point over 2 places to create a 4x. That means I need to move all the decimals on the second equation over 2 places. So I get 4x plus 60y equals 80. Every decimal gets moved 2. Now, the only reason I did that is because it's easier to work with, like no decimals, right? Now I'm going to solve this. I have 2 options on how to solve this. I can do either substitution or elimination. And I told you I didn't care which one you do. I'm going to do elimination, which means I'm going to multiply this top equation by 4 so that I can get the x's to cancel. I need a negative 4x here to make these x's cancel. So if I multiply this through here, here, and here, I get negative 4x. I get negative 4y equals, let's see, negative 32. And that gives me 4x plus 60y. Nothing changes on the second equation. But the whole purpose of doing that is so that now when we add these 2 equations together, we add down. We get the x's to cancel, so nothing. Here we get 56y equals, what is that? 48, I think. All right. Yeah. I'm getting my calculator because I'm about to need it. So now I'm going to divide both sides. I know what y is, right? Or sorry, 56y is 48. So now I take 48 and I divide it by 56. And I get y is equal to 0.8, let's say 86, I'll round it. Now I know what y is. Once I know y, I can go back to any equation I want here and solve for x. I'm going to pick this one right here because it's the nicest one. I know that x plus y must be 8. But I now know that y is 0.86. And now what I'll do is I'll subtract, right? I'm going to subtract 0.86 on both sides. And yes, you're going to get a bigger number. You're going to get 7.14. So the answer to the question is this. If you take the 4% solution and you take 7.14 pints of it and you mix it with this 60% solution and you only do 0.86 pints of that, if you were to do that, pour in the 7.14 pints of the 4% acid and the 0.86 pints of the 60% acid, stir it up, you'll have 8 pints of 10% acid solution. I hope it makes sense to you that you need a lot of the 4% and just a little bit of the 60%, because the 60% is very strong. So if you put too much of that, you're trying to get a 10% acid solution at the end. So, you know, the 4% is pretty close to 10 already. 60% is really far away from 10. So you don't need much of this. While we're here, let's do these 2 problems. Converting these to scientific notation. We take this decimal point, I move it 1, 2, 3, 4, 5, 6 places to create a 3.25. How many places did I move it? 6? To the left, right? So if I go to the left, I'm going to put a positive 6. On the second one, I move 1, 2, 3, 4 places to create a 1.25. And since I moved it to the right, I do a negative 4. All right, we have 9 minutes. There's not a whole lot we can do in 9 minutes, but is there anything, any questions you have grade wise, anything?
So that homework assignment that you had gave us, I know you had mentioned extra credit. Are we still going to be getting extra credit for that or?
Yeah, so here's what I like. Which one, are you talking about the one that I asked you to have? Which one are
Yes.
you referring to?
It was the solution one.
Yeah, so I would say anything that you have as far as extra credit that you've done by hand, I would like for you to submit that with your test.
Okay.
All right, but I'd like it to be like all your exam work, then your reference sheet, then your homework problems or extra credit. Okay,
All right. Sounds good.
that way they're separated.
And does that go for all of the homework that we've done like all semester as well? Or how do you want us to do that?
No, I don't want you to submit all your homework. No way, that would be crazy.
That's why
Yeah, that'd be crazy.
I just wanted to clarify. Okay.
Yeah. Let me check something real quick. Let me look at something. Give me a moment here. Yeah, so, okay, that's what I want to make sure we were clear on. So we never did the exam 4, right? That was on our calendar. So I already told you that after you take your final, I'm going to take a look at exam 1, exam 2, exam 3, and the final. But I'm going to look at all 4 of those grades. And I'm going to take your highest grade out of those 4, and that's what exam 4 grade will become. All right. And then other than that, let me see if there's anything else here. Yeah, other than that. I will also, what it's going to come down to is, let's see how the exams go, what the grades are at the end. What I will do is at some point, you'll take a look on Canvas and you'll see your grades, right? Nothing goes completely official until, let me see, I have to have grades posted officially by Monday, the 13th of December. That's when I have to. So in Canvas, your grades will appear in Canvas, but then I have to go manually put in like a letter grade, A, B, C, D, or F. Those are the only options I have. I have to put that grade in by the 13th. So when you take your test, just keep your eyes open for the exam. When you start to see your final exam grades show up and stuff, then you'll kind of know where you are in the class. If there's any questions about your grade, you'll need to reach out to me before the 13th. But I also want you to keep in mind that you are one of 6 classes that I have. So it's always at the end of the semester when I start to hear from people like, oh, I only need 4 points and I'll get a B, right? Like, you have to be realistic about things. If you have a 77.8 in the class, you're going to get a C, all right? I mean, it's just, the problem you run into is this. I mean, this is every semester. This is my worst time of semester because I have to deal with grades. So here's the issue. Let's say that you have a 78.7% in the class. Let's just say that's where you are. And so you send me an email and you're like, hey, sir, I really, really, really wish that I could just get maybe 1 extra point, right? 1 point. Because if I get 1 point, then I'll have a 79.7, and then that will round up to a B, right? Which I would agree, that would round up to a B. All right, I will round up, okay? But I'm not going to round a 78.7 up to an 80. I'll round this to an 80. So let's say you're sitting there going, I really want 1 point. And I'm like, I'm not going to give you 1 point. You're like, well, he's being a jerk. Here's the reason why. If I give you 1 point, right, then I give everybody 1 point. It's not, nobody gets special treatment, okay? everybody gets 1 point. Now, you can make an argument, hey, sir, I was always in class. I always had the video on. I was always participating. Like, I know who's had their video on, and I also know who's responded every time. I always hear the same people. So then you can make an argument, but you can't make an argument if just like, hey, I want a point, give me a point. Here's why I can't give you the point. Because you have another student who has a 77.9, right? And since I'm giving you a point, I'm giving everybody a point, right? To be fair, right? That's fair, because it would be complete bullshit if I gave one of you 1 point and nobody else got that 1 point for nothing, right? So now this student looks at their grade, right? And then now they have the 78.9. So what do they really want now from me? They really would like 0.6 points, because now 0.6 points makes them have a B. And what happens is you get this like snowball effect, where 1 point for one student starts to become more than it just creates problems. All right. So please understand that I will be as fair as I possibly can in terms of the grades. There's 20% of your grade right now, right? Isn't there 20%? Let me look at this, double check. There's 20% of your grade. I need to look at this, hold on. No, 2, 4, 6, 8. Yeah, okay. I apologize. I misspoke. All right, so there we go. Yeah, I will be as fair as I can. I think by me replacing your exam 4 with the highest, that benefits everybody in the class. So I just want you all to know I'm not trying to be mean to you. Okay, it's more of just, please understand from my perspective that when you start giving people points, it really does impact the whole class. And as time has gone over the years, it's been a little bit shocking, because I'll have students that have like a 76 in a class and they want to be, you know, it's like, I can't round you up 4 points. Like I just can't do that, you know? So I'm always available if you want to talk about your grade. I'm not telling you not to contact me, but before anything, I just want you all to know kind of where I'm coming from. So, all right, let's get through the test. We'll deal with grades after that. Yeah. Anything else?
Yeah. What are we to submit? What are we going to submit with the exam question on the reference sheet?
Wait, what?
For the exam, you said we are going to submit. We have to submit the exam, then the
Yes.
reference sheet,
Mhm.
then a particular test. A particular homework. What's the
Yes.
homework?
Yeah, it was that mixture problem that I gave y'all.
I believe it was from the 23rd of November.
Yeah, I'm not gonna say when it was from. I'm just gonna say, you know. Yeah,
It's in
there
your
was-
email, because it's in an email, so it's in there.
Sorry.
Yeah.
Yeah. Got it. Thank you.
Yeah, it's an extra credit, right? I mean, I'm gonna count as extra credit. Now, it's not gonna be this huge thing that's gonna, you know, add 10 points to your final. It's just a little something, right? Because if we do get down to the point where we're talking about, you know, hey, I just need 0.3 points. Like if you have, oh, I turned in the extra credit, I was always in class, you know, you have more to work with. So it's just to benefit you. All right. Well, everyone, I appreciate the participation this semester, the Zoom, you know, doing this class in Zoom and everything else. I hope it's been okay for you. I know it's hard for me to be doing Zoom, but I know a lot of students, this works out for them in terms of life and schedule and everything else. So this was a terminal math class, so I'm expecting none of you are taking any more math. If you go try and get into pre-cal right now, if you go try and take pre-calculus right now, as far as your transcripts, you could do it, but as far as what I've shown you in this class, you're not ready for it. And I warned everyone about that in the beginning. Like if you wanted to, take that other college algebra, you go do that. This was just to make sure that you can still go pursue your degree without letting math stop you. So I really wish all of you the best luck ahead, and look forward to seeing you on the final, and hopefully you'll be relaxed, calm, well rested, fed, good karma, good vibes. All right, everyone, we're over time. I will send out the
Thank you.
solutions. I will send out the solutions for what I have for the review. Give me a day or two. I'm gonna let y'all work on it a little bit on your own first.
Thank you for
Thank you.
everything.
Okay, thank you, everyone. Y'all have a good
Thank
day.
you.
Good luck on your other finals.
Thank you.